In this video, we will be dealing with purification method 2 or separation technique 2. As you know, there are many methods of purification for solids and liquids. But firstly, the choice of the method of separation would depend on the nature of the substance being separated. Secondly, as I earlier mentioned in one of my videos on separation techniques, the separation method will also depend on physical properties such as the boiling point, the melting point, solubility, density, sublimation, and the magnetic properties. And finally, we can now use the differences in the properties to choose our method of separation. For instance, we use the difference in solubility to choose a suitable solvent as we did in paper chromatography. We will also use the differences in the boiling point of liquid to choose the distillation apparatus, just to mention a few of these ones. Now, starting fully, we are asked, describe and explain the method of purification by the use of a suitable solvent, filtration, crystallization, and distillation. You know very well, as I said, there are many methods of purification. We are starting with separation of insoluble solids. How you can separate insoluble solids. Purification of undissolved solids. Our example is sand from a mixture of sand and water. What is the separation technique that is used? What is the separation technique that is used to separate sand from a mixture of sand and water? The separation technique here is filtration. And what is filtration? We use filtration in our daily lives. We filter our tea. We filter many other things, even water. We filter a lot of things in our daily activities or home activities. What is filtration? We say this is a method that is used to separate an undissolved solid from a mixture of the solid and a solution. Our example was sand from a mixture of sand and water. Here, using filtration, we need a funnel, we need a filter paper, we need the solution that has to be separated. What happened is that the filter paper is placed in a filter funnel above, and the mixture of insoluble solid and liquid is poured into the filter paper. The filter paper will allow only small liquid particles to pass through as filtrate into the beaker. Then the solid particles are too large to pass through the filter paper, so they will stay behind as residue. As observed here, that is what happens in filtration. Another method, another method that can be used, or technique that can be used for the separation of undissolved solids, is centrifugation. The use of a centrifuge. The use of a centrifuge. This method is another way to separate a solid from a liquid. Centrifuge they are used to separate solid, small particles of solid that are dispersed in the whole liquid, in the whole solution. What happens is that when in a centrifuge, when it is spinning, when it spins, what happens? What happens? The small particles settle at the bottom of the test tube. So this technique is sometimes used. It is sometimes used in filtration. Usually, it is used when the solid particles are too small, they are too small and spread throughout the liquid, or remain in the liquid as in suspension. So when we use this, as you are spinning it, the small particles become closer to each other and gather at the bottom of the test tube. Our second method of separation is separation of soluble solids. The first one was separation of insoluble solids. Now we go to separation of soluble solids. Separation of soluble solids. The purification or separation of a dissolved solid. We are talking of copper sulfate from a solution of copper 2 sulfate in water, or salt from water. How can you separate soluble solids? What technique is used in the separation of soluble solids? The most common technique used in this process is crystallization. Crystallization is the method used for the separation of soluble solids. So it is used to separate dissolved solids from a solution. Our example was copper sulfate from a solution of copper 2 sulfate in water. What you do here in this process of crystallization is what? Remember, there are some solutions that will dissolve when in a hot solvent. Copper sulfate from a solution of copper 2 sulfate in water will dissolve faster in a hot solvent. So in that case, it is more preferable to heat the solution. Unlike in salt. In salt, we will not heat the solution. We just need to dissolve. Salt from water. We just need to dissolve the salt in water. But with copper sulfate from a solution of copper 2 sulfate in water, this one will dissolve faster in a hot solvent. So in that case, when we need to heat the solvent so that the copper solution will dissolve faster. The copper sulfate salt will dissolve faster. So the first procedure is heat solution. The solution is heated, allowing the solvent to evaporate to leave a saturated solution. But how do you know whether the solution is saturated? Test if the solution is saturated by dipping a clean, dry a cold glass rod into the solution. If the solution is saturated, crystal will form on the glass rod. The saturated solution is allowed to cool slowly, and the solid will come out from the solution. Now the crystals will now increase in number. So our next step will be what? To filter out the crystals. Crystals are collected by filtering the solution. After we filter the crystals, after we filter and collect the crystals, the last stage will be to wash and dry the crystals. So wash and dry the crystals. They are then washed with cold distilled water to remove impurities and allowed to dry. It's a simple method. Heating the solution, filter the crystals, wash and dry the crystals. See how it is illustrated here. A solution in water, soluble solid in solution. We heat to evaporate. We heat to evaporate the water so that the concentrated or the saturated solution is left behind. Then what happens? We use the concentrated or the saturated solution to do what? We filter off the crystal from there. We filter off the saturated solution. We will now filter off the saturated solution using what? Using the funnel and the filter paper. The filtrate of copper 2 sulfate will get into the beaker. We now use this filtrate. We will now use this filtrate to do what? We will now wash them and dry. Crystals of soluble solids. We now wash them and dry. This is a simple question there, often asked in the exam. How would you separate a mixture of two solids in solution? How will you separate a mixture of two solids in solution? One is soluble and the other one is insoluble. The simple thing is an example. You give an example for it. Salt and sand. How will you separate a mixture of these two solids that are in solution? We have an example is salt and sand. Now, dissolving the mixture of sand and water in water, the salt dissolves and the sand doesn't. Here we start. Now, our answer starts from what? From filtration. Our answer starts from filtration. Step 1, filtration. Filter the sand residue from the filtrate using the filter paper. After filtering the sand, what happened? The next step is evaporation. Evaporate the water in the sand solution using evaporating dish. The next step is cooling. Allow the hot saturated salt to cool. And the last one will wash and dry. Salt crystals are washed with little water and dried in a low oven or warm air. That is just all. How you can separate a mixture of two solids in solution. How you can separate salt from sand. Salt is already in sand. That is a solution. What do? You start with filtration. You filter off, you evaporate, you cool, and you wash and dry. Now it takes us to another method of separation. Another method of separation is separation of miscible liquids. Separation of miscible liquids. What are miscible liquids? Miscible liquids are liquids that can mix together. They cannot be easily identified with each other. You mix them together and you cannot easily identify them. You cannot physically, you cannot identify them. They are mixed together. Let's start with this. Purification or separation of a pure liquid from a mixture of liquids. Separation of a pure liquid from a mixture of liquids. Or separation of liquid. Separation of a liquid and a soluble solid from a solution. Our example is water from salt solution. Water from salt solution. Water from salt solution. These are miscible liquids. In this case, what do you do? The simple method is distillation. Distillation. This simple distillation method, the simple distillation method is used to separate a liquid and a soluble solid from a solution. I said example was separating water from a solution of salt water. This solution is heated. In this case, how you can separate water from salt solution? What you do is the solution is heated and the pure water evaporates, producing vapor. The vapor rises through the neck of the round bottom flask. The vapor passes through the condenser where it cools and condenses and turning into pure water that is collected in a beaker. After all, the water is evaporated from the solution. Only the solid solute will be left behind. This is a good example here. This is the apparatus used for simple distillation. This is the apparatus used for simple distillation, where we have the round bottom flask with a thermometer, and we have the condenser, and we have condenser with two arrows, one pointing the cooling water in that will help to cool down the steam, and the other one that will after cooling causing the steam to condense. What happened? The water that was used for cooling goes out. Then the condensed steam now comes out as distillate collected in a beaker. Our example above is illustrated here. Our example is illustrated here. Here you have salt water. This is salt water or salty water. Now heat is applied. When heat is applied, what happens? The salt water boils. When the salt water boils, what happens? Vapor, water vapor is given out. As the water vapor rises to the neck of the round bottom flask, it passes into the condenser. Within the condenser, there is an entry of cooling water that enters to cool the vapor and causing it to condense. So the water goes in, the cooling water goes in to cause the vapor to condense. After cooling and causing the vapor to condense, the water now goes out as waste. The vapor that condenses into pure liquid is now collected in a beaker as pure water. That is a simple procedure. Learners, at times you could be given this diagram in your exam and you are asked to label what is happening here, what is happening with this vapor. They could just give the arrows there, they put the arrows, put the empty spaces for you to label. And they may decide, again, examiners are very trickish, they could decide and change the arrow. That where is there a mistake? And change the arrow and ask you to see where there is an error to correct. So you should study the diagram, know what is happening, what goes in, what comes out, where condensation is taking place, and when they distillate, is the condensed vapor comes out and where it is being collected. So it is very important for you to understand this diagram and how it works. Thank you. And that is how you can separate. That's how you can separate water from salt solution. Separation of miscible liquids using simple distillation method or simple distillation technique. Another question number 2. How would you produce pure water from sodium chloride solution? The examiner could turn the question in one way or the other. It is the same way. It is just what we have discussed here. It's just the same thing we have discussed here. It's the same thing. Salty water, that is it. From sodium chloride solution, that is salty water. Salty water is a sodium chloride solution. So it's the same procedure we have outlined above, using the same simple distillation technique. Evaporation of the water in a round bottom flask. The water rises up to what? Rises up to the neck of the round bottom flask, passes into the condenser. What happens? There is and the vapor is being condensed. The vapor rises up and passes into the condenser, and it is being condensed by what? By the cooling water that gets into the condenser. And when it is being condensed, what happens? The water now comes out as pure water into the beaker. It's the same thing. It's the same procedure. While the sodium chloride will remain in the round bottom flask. Now the other section is separation of miscible liquids. Separation of other miscible liquids. Separation of miscible liquids. There are other miscible liquids that can be separated. There are other miscible liquids that can be separated. We are talking of purification of 2 or more miscible liquids with different boiling points. The property we are going to use here is the boiling point. Separation of 2 or more miscible liquids with different boiling points. An example is ethanol from water. Another one is separating the different hydrocarbon in crude oil. Another one is separation of nitrogen gas from a mixture of air, from air mixture through the fractional distillation of liquefied gas. So in this case, how would you separate 2 or more miscible liquids with different boiling points? Example, ethanol from water, crude oil, ethanol from water, different hydrocarbons in crude oil, nitrogen gas from an air mixture. The simple the technique usually used for these examples is fractional distillation. Fractional distillation. It has to do with temperature. Temperature change. The property is the boiling point. So this method is used to separate 2 or more liquids that are miscible. I just gave the example ethanol and the water from a mixture of the 2. Miscible hydrocarbons in crude oil. Separation of individual gases such as nitrogen from a mixture of gases in the air. And even to remove ethanol from the product of fermentation. The solution is heated to a temperature of the substance with the lowest boiling point. So now we have to heat it till it gets to the temperature with the substance with the lowest boiling point. This substance will rise and evaporate first, and vapor will pass through the condenser where it cools and condenses, turning into liquid that will be collected in a beaker. All of the substance is evaporated and collected, leaving behind the other components of the mixture, depending which one we want to evaporate. So in this case, this is a good diagram of a fractional distillation. We have a liquid to be distilled. This is a mixture here, solution mixture. These are miscible liquids with different boiling points. Now, when they are being heated, what happens? They rise up. But remember the liquid, or remember the liquid we are going to separate. If we are going to separate the liquid with the lowest boiling point, then it will heat. When after heating, we should look at the thermometer. When it gets to that level, with the substance with the lowest boiling point, we stop. We will stop from heating. We will stop the heating and allow only that with that temperature to be evaporated. And when it is evaporated, what happens? It goes into the condenser. Cooling takes place, and now it is picked up or collected as distilled liquid. We want to take example from fractional distillation. Our first example, which is question number 3 for fractional distillation, will be: how would you produce ethanol from a solution of water and ethanol? How would you produce ethanol from a solution of mixture of water and ethanol? Now, for water and ethanol, our method, we use the fractional distillation method. The instrument is the one we have just talked of. That is the instrument to be used. Now, what happened is this: ethanol has a boiling point of 78 degrees Celsius, and water has a boiling point of 100 degrees Celsius. So we have to heat to the degree of ethanol, not to water. We don't want water to get into it. So the next thing is the mixture is heated until it reaches 78 degrees Celsius, at which point the ethanol boils and distills out of the mixture and condenses into the beaker. When the temperature starts to increase to 100 degrees Celsius, heating should be stopped. At this level, we now know ethanol and water are separated. If you go into 100, you are now distilling water. You want to get water into the ethanol. So you have to heat until the temperature reaches the one with the lower boiling point, which is ethanol. That is 78 degrees. At 78 degrees, no more increase in temperature. You have to stop the heating. And at this level, we know that only ethanol is being collected. And this is how it is. Remember, it is more advisable to use electric heater. It is more advisable to use electric heater because ethanol is flammable. If we should use a Bunsen burner here, ethanol, which is more flammable, the ethanol that is more, that will be released here as distillate or collected in a beaker here, because it is more flammable, it can get into fire if a Bunsen burner was used. So it is more preferable to use an electric heater because ethanol is flammable. That is a simple fact. Now, let's go to the last separation technique, the one we use to separate immiscible liquids. Immiscible liquids. We have miscible and we have immiscible. We are done with miscible liquids. We now go to immiscible liquids. What are immiscible liquids? Immiscible liquids are liquids that cannot mix. If you mix them, they cannot form a uniform solution. They can't form a uniform solution. If you mix them together, what happens is that you are going to see physically you will see them either in layers. An example is oil and water. Oil and water it is different. The density of water is different from the density of oil. So you know that water is more dense than water is more dense than oil. So what happens? Oil will flow on water. So density density is now coming into play. Density is now coming into play. Water will go below and the oil comes above. You can still use that in the separation between water and kerosene. Water and kerosene. In this case, it is water and oil. You can separate immiscible liquids with a separating funnel by the process of decanting. 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 Either you use a separating funnel or by decanting. Example of this organic when an organic product is formed in an aqueous condition. An organic product is what is a thing like kerosene. An organic product is what is a thing like oil. So how can we separate oil and water, or how can we separate kerosene and water? It's the same method. Either we use separating funnel or we use the process of decantation. Here we have two instruments that are well outlined there. In this case, this is a separating funnel. Here in the separating funnel, you see how water is there and the oil is there. They are separated by layers based on their density. We have a conical flask, and we have a stand here where the conical flask is placed on it. When you put like this, water will come out first. And what happens? When it gets to this level, you stop it. You open the tap, and water will comes out. As water comes out, when it gets to this level where water ends, you close the tap. And you now collect your water separate from the oil. The same thing goes with kerosene and water. You can use if you are not using a separating funnel, you can use the process of decantation. In the process of decantation, this is another process. The process of decantation here, you can use you have the beaker there. Then you have to pour it into the collecting beaker carefully. Make it to settle and try to collect it using a collecting beaker by pouring it gently. That process is called decantation. These are two methods that you can separate. You can separate immiscible liquids, liquid that cannot mix up to form a uniform solution. Now, we go now to the next section of our separation technique. If given the information, you are given the information about a particular substance, and the examiner now asks you, suggest suitable purification techniques. You have a number of techniques in your brain. You have to choose a suitable method given the information. So learners know the substances, know information about them, and know suitable methods or techniques that can be used in their separation. A recap of our lesson. If given the substances and the information about it in an exam, and you are asked to choose a suitable separation method, what will you do? Number one, you are given sand. Example of a mixture. You are given sand and water, and you are asked, what are the properties used for this? Solubility. we will use the property of solubility to separate the sand from the liquid, from the solid from the liquid. And what is the technique, or what is the method? The method is filtration. 2. A mixture of sodium chloride solution. We will still use solubility to separate the solid from a solution. And what will be the method? The method will be evaporation. Evaporation. 3. Using a mixture of sodium chloride solution. It's use solubility to select a solid from a solution. And what will be the method? Is crystallization. Using sodium chloride solution, boiling the boiling point could still be used to a boiling point could still be used, and that is simple distillation, which we mentioned the other time. Ethanol and water, we will use this. Boiling point will be used. Boiling point of ethanol 78 degrees Celsius and water is 100. So we will use to separate the liquid from each other, and that is a fractional distillation. Now, colors. A mixture of dyes. What will the property? The property here will be absorption. Absorption by paper and the solubility in solvent. This will use to differentiate the substances into their different components. And what technique is used to differentiate or to separate the different dyes or the different components in the dye? We use the paper chromatography. The last one is salt and sand. Solubility is used. And salt and sand, what is the technique? The technique here is where we use dissolving, filtration, and crystallization to separate sand and salt. We dissolve the sand, we dissolve the mixture, we filter it off, we heat, formation of crystals, washing and drying. So dissolving, filtration, and crystallization for salt and water. Now, let's go to the last part of it, which is a past paper. This is just part of a past paper. For examiners to know, for my learners, this is just an example of what we have just done. This is a past paper, a part of a past paper. Question number 1. The diagram shows the apparatus used to separate a mixture of water, boiling point 100 degrees Celsius, and ethanol, boiling point 78 degrees Celsius. This is the diagram. That is the diagram there. You have the diagram there, quite all right. You have the stand here. The stand here, that is the tripod. Being under the tripod, you have the heat. There is a mixture of ethanol and water here. There is the collecting beaker. Under the collecting beaker, there is a standard for the collecting beaker. There is heat on the collecting beaker. I don't know why. There is water entering here, and there is also water coming out here. The cooling water enters here to cool the steam that comes out from the fractionating column. It condenses it into pure water, and when it condenses it, the wastewater that was used for cooling goes out, and then the pure water that condenses into the vapor that has condensed into pure water now comes out as the pure water. The question now is, complete the boxes to name the apparatus. A. Okay, we can say we start from here. The first one here is called the fractionating column. The first one here is called the fractionating column. Then the second one here is called the tripod, where you stand the round bottom flask. This is the tripod. Once more, this is the fractionating column here, There's fractionating column. Put in this space fractionating column. Come below here, put here tripod. Question number 2, or the B part of it. Label the arrow. Label the arrows on the condenser. These are the arrows on the condenser. Here we write this one. Since the arrow is going in, we say cooling water in. Cooling water in. Now, since the arrow is going out, we now say waste water. We can say water out. Water out. C part, identify one mistake in the apparatus. Well, you look at the apparatus very well, you will see that under the collecting beaker, there is heat there. Under the collecting beaker, there is heat there. There is not supposed to be heat here. You are collecting, this is the distilled, this is for the collection of ethanol. This is ethanol that has been collected here. This is ethanol that has been collected here. We cannot heat it again. We cannot heat it again. So the mistake is putting heat on, putting heat under the collecting beaker. Putting heat under the collecting beaker. That's what you are supposed to write. One mistake is putting heat on the under the collecting beaker. So you are not supposed to put heat there. So the mistake is putting heat there. That's the mistake that was done. The D part of it. The D part of it. Which liquid collect first? Explain your reason. We did ethanol. We did the separation of ethanol in our lesson. We know that the liquid that separates first is the one with a lower boiling point, and the one with the lower boiling point is ethanol. So the question is, which liquid will collect first? The liquid that will collect first here is ethanol. Ethanol will be collected first. Our reason is that because ethanol has a lower boiling point than water, and it will be evaporated first. Reason, because ethanol has a lower boiling point than water, it will be evaporated first. So that is it. Again, question number, the E part of it. The E part of it, which is the last section of the question. Why would it be better? Why would it be better to use an electric heater instead of a Bunsen burner to heat the water and ethanol mixture? As I did mention in our lesson, ethanol is flammable. Ethanol is flammable. We cannot use a Bunsen burner. If we use a Bunsen burner, it is not safe. It is going to be flammable. It will need fire. If there's a Bunsen burner, it will need fire. So it is not advisable to use a Bunsen burner. It is better you use an electric. It is preferable to use an electric heater because ethanol is flammable. Your reason is because ethanol is flammable. If you answered all your questions from A, B, C, D to E, you will have a total of 7 marks. This is what you are expected to do. Thank you, learners, for listening. Continue to listen. Continue to watch more of our videos. Continue to watch more of our videos. Please like, share, and subscribe so that you can get more of our tutorial lesson video. Thank you.